Okay, today we get to talk about properties of operations. So we just reviewed order of operations all last week. Along with order of operations, we have properties of operations as well. There are 4, and we're really going to focus on 2 of them. The first one that we're going to talk about today is commutative. C-O-M-M-U-T-A-T-I-V-E. Commutative. Everybody say commutative. 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 Very good. The next one is associative. Associative. Yep, say it again. Associative. Those are the 2 big properties that we are going to be focusing on, but we have 2 more that are good to know because you're going to see these. One is called the inverse operation. You don't have to say that. Inverse operation. And identity property of 0. So you see this little note off to the side with that little kid. It looks like Charlie Brown's shirt, but he has hair, so it's not Charlie Brown. And it says mental math. Okay, using properties can make adding and subtracting whole numbers easier. It can also make multiplying and dividing numbers easier if you use your properties. Now what we're looking at here, these are using adding and subtracting. Okay, same thing goes for multiplication and division. So if I'm looking at the commutative property for addition and subtraction, it says the order of the addends can be changed around. The order of the addends can be changed, and the sum remains the same. Same thing is true for multiplication. If I were to have, looking at this example, 12 plus 3 plus 8, I could reorder that and do 12 plus 8 plus 3. Or I could do 8 plus 3 plus 12. It doesn't matter the order that I add them in because I'm just combining all of those together. We'll say I instead had a multiplication sign here. And I did 12 times 3 times 8. It's the same thing as doing 12 times 8 times 3. Or 8 times 3 times 12. You would still end up with the same answer. So it works for adding and multiplying. But it won't work with subtraction or division, because if I change this to minus 12 minus 3 and then minus 8, well, if we did our order of operations rules and worked left to right, that would be 9, and then minus 8 would be 1. But this would be 4. Oh, well, and minus 3 would be 1. But this one won't work. 8 minus 3 is 5, and then minus 12, you'd end up with a negative number. So it doesn't always work for subtraction or division for that matter either. Okay, because 12 divided by 3 is 4, divided by 8 is 1/2. 12 minus 8, or 12 divided by 8, you can't, that would be a decimal number or a fraction. So it doesn't work when you're going backwards. Does that make sense? If you're adding or if you're multiplying, you can change the order of how you add or multiply of those numbers. It doesn't matter which ones you do first because you're going to end up at the same answer. Okay, what about associative property? Well, for addition, it can also apply to multiplication too. The addends can be regrouped. So this is going to be a little different because I'm going to group certain things in parentheses. I can regroup them, however, and the sum remains the same. So notice my example says 17 plus 6 plus 3. If I put parentheses around 17 plus 6, and then I used order of operations to solve that, I would do 17 plus 6 first, which is 23, and then plus 3, which is 26. Okay, well, what if I put parentheses here instead of 17 plus 6? Then that means I would do 17 plus 9. And 17 plus 9 is 26. So you're just grouping different numbers. But because you're still adding everything together, it still turns out to be the same. Same thing is true for multiplication. If those were multiplication symbols, it wouldn't matter which ones you multiplied first. Okay, the way I used to always teach commutative versus associative, think about like who you associate with at school. Okay, you kind of like have maybe a group of friends that you hang out with at school. But then maybe you go off to your sports team and maybe or church, and maybe your friends are different. You kind of group yourselves with different people in different situations. Okay, but the way you are and the person that you are is going to stay the same. So it doesn't matter where you group yourself, you're going to stay the same. Okay, but your group can change. Commutative, commute. Does anybody know what the word commute means?
Communicate?
Commute. Just commute, not communicate. Commute. If I commute to and from work every day, what does that mean? Travel. Okay, so commute. I'm going back and forth. I'm commuting. I'm going to and from a place. These numbers can be moved around. They can switch places, and the answer is still the same. Okay? All right. Let's look at the last two examples. Oh, I didn't write in my answers here. These were all 23. We talked about it, but we didn't actually write them down. Okay. I also have two other properties. I have the identity property and I have the inverse operation property. The identity property of 0 is when 0 is added to a number, then the sum is that same number. So for example, if I add 0 to 8, then my answer is still 8. That just hasn't, we already know how that works, but it has a name. It is the identity property of 0. It is true for multiplication in a different sense, because if I multiply anything times 0, what's my answer? 0. So it's slightly different. Okay, inverse operation. Inverse. What does inverse mean?
Reverse it. I don't know.
When I talk about inverse in math, I'm talking about the opposite.
Okay.
Or reverse operations. And they undo each other. This is what we use a lot of times when we are checking our work. So if I do like long division and I get an answer, remember I would say you can actually check to make sure. You can take your answer and multiply it by the divisor, and if you get what's in the dividend, then you know you did it right. So you can use the inverse operation a lot of times for checking things. So if I do 3 plus 5, I get 8. To check my answer, I could take 8, subtract one of the add-ins, 3, and I end up with the other add-in, 5, so I know I did it right. Those are called inverse operations. 3 plus 5 and 8 minus 3. Those are inverse operations. Same thing here. 5 plus 3 is 8. 8 minus the other add-in, 5, equals 3. They're like fact families. Okay? The opposite or inverse of addition is what? What's the opposite? Subtraction, right. And the opposite or inverse of subtraction is? Addition. What about multiplication? What's the opposite of multiplication or the inverse? Division. And so the inverse of division would be multiplication.
Oh, wait, what about fraction?
Opposites. Well, a fraction is a division problem. So the opposite or the inverse would be multiplication.
Wait, if the fraction's a division, what if you're multiplying the fraction?
Well, just a fraction is a division problem. Like one fraction is top number divided by bottom number. All fractions are actually a division problem.